This exam application tutorial is on ionic bonding. The question for 6 marks: explain why sodium chloride has a high melting point and conducts electricity only when molten or dissolved in solution. So, describe the structure of sodium chloride. Why do ionic compounds have high melting points? Why do ionic compounds only conduct electricity when liquid or dissolved? So you need to basically identify the structure of sodium chloride first of all. Sodium chloride is a giant ionic lattice. It looks like this. So a lattice is a structure with a regular arrangement of atoms, so in rows, for example. Now, to describe a giant ionic lattice structure, it consists of ions of opposing charge or opposite charge, so positive, negative, next to each other. Now I'm going to explain why it has a high melting point. The ions are held together by strong forces of attraction, and this gives sodium chloride a high melting point. So you could try heating up in a pan, but it would take a lot of energy to melt it, to overcome those forces of attraction and separate out the ions. So as a solid, the ions cannot move. So this will help us explain the second part of the question, why it conducts electricity when molten or dissolved only. So in a solid, these ions can't move. They're charged particles here for sure, but unless they're moving, you will not get an electric current flowing through this circuit. However, when liquid or dissolved in solution, the ions are free to move so they can conduct electricity. So if we're basically putting electrodes into liquid or dissolved sodium chloride, we would conduct an electric current because these ions are now free to move, so they can transfer electrons into the wire and electricity flows around the circuit. So the key idea is in solids the ions can't move, but in liquid or dissolved the ions are free to move so it can conduct electricity. Electricity is simply a flow of charged particles, and these are charged particles and now they can move, they can flow.